Okay, so you've already done a lot of things with the unit circle. You're pretty familiar with it from not only last semester, but also Algebra 2. And so in the unit circle, we always had a radius of length 1. But now we're going to have a radius of any length. It doesn't have to be length 1. Okay, so we're going to talk about definitions of trigonometric functions of any angle. So we already know that sine of theta, if I was talking about, you know, a right triangle with an acute angle theta, then sine would be opposite over hypotenuse. So it would be the y value over the hypotenuse, which we're going to call r. And it's the same thing here. So even if we have an obtuse angle or an angle that's acute, then we still have the y value over r. Same thing for tangent. Tangent was always opposite over adjacent. So it was the y value divided by the x value. Same thing here. Secant is going to be 1 over cosine. So cosine was x over r. So when we do the reciprocal, we get r over x. Cotangent is the reciprocal of tangent, so it's x over y. And cosecant is the reciprocal of sine, so it is r over y. So you might want to write in your notes, cosecant is the same as 1 over sine, and then secant is the same as 1 over cosine, and cotangent is the same as 1 over tangent. So we'll be using those a lot. Since r can never be 0, sine and cosine are always defined. However, there are some radian measures in which tangent and secant are undefined. So let's think about it. So when tangent and secant are undefined, that means that we have the x value and the x value on the denominator. So we need to think about, like, especially on even back to our unit circle, when is x equal to 0? So if you kind of sketch out a little unit circle, the x value is equal to 0 here and here. And that's exactly the same for this one as well. So the x value is equal to 0 at pi over 2 and 3 pi over 2. So even if we have r is bigger than 1, it's the same idea. So it says what radian measures would make cotangent and cosecant undefined? Well, cotangent and cosecant have the y value set equal to 0 then when it's undefined. So the y value is equal to 0 here and here. So that's going to be 0, pi, and also 2 pi. Okay, so why is this important? Why do we have things where we have the r value is not equal to 1? Because clearly you're familiar with the unit circle. Why do we have to do this? Because we might have problems like this. So it says let negative 4, 3 be a point on the terminal side of theta. So we sketch it out, and we're like, okay, negative 4, 3. So I'm going to have right there. So that means that I have my terminal ray here, and my theta is the angle all the way from my initial ray, which goes off towards 0, and then the terminal ray. So we want to find the sine, cosine, and tangent of theta. So what we do is we treat it just like the acute angle. So what we really have is, it's not really theta, but we're going to talk about this in a second, which is like theta prime. It's like a reference angle. And its sine, cosine, and tangent are exactly the same as our original theta. So if I talk about the sine, then I went up 3 units and I went left 4. So I'm going to make sure that I keep those signs, right? Negative 4 and positive 3. So when I talk about the sine of theta, it's the y value over the r value. So we still need to find what our r is. So we had negative 4 and we had 3. And r is always positive. You're never going to have a negative on your hypotenuse. So we're always going to have a positive there. So we find it. So we do 3 squared plus negative 4 squared equals r squared. And I think you guys know the 3, 4, 5 right triangle. You end up getting r is equal to 5. So we put 5 there. So that means that our sine of theta is equal to the y value over the r value. So it's 3 over 5. Cosine of theta is going to be the x value over the r value. So negative 4 over 5. And tangent of theta is going to equal the y value, which is sine over cosine, right, x. So it's really, I mean, the long way would be y over r over x over r. But those r's end up canceling if you think about sine over cosine. All right, so that ends up being 3 over negative 4, so I'm going to write negative 3/4. Okay. And obviously they get a little bit harder than this, as you know with math, right? So the next one says, suppose sine of theta is equal to 3/5, and now it tells us that theta is in quadrant 2, so that means that we're bigger than 90 degrees and less than 180 degrees, or if you were talking about radians, it's between pi over 2 and pi. Okay, so when we sketch this out, we know that this is the y value over the r value. So I have 3 and I have 5. And if you try to find this, well, it's the same as what we just did. It's a -4. So when we talk about the cosine of theta is -4 over 5. So exactly the same process, just worded a little bit differently. So when they say something like theta is in quadrant 2 or quadrant 3 or whatever, you can sketch it out appropriately. You always want to think about your signs of your x and y in particular. Okay, so the next one says tangent of theta is equal to -15 over 8. So this is a little bit harder when it's set up with tangent. You really have to think about it. Okay, so we have the y and we have the x, but it's a little bit tricky because y isn't necessarily -15. I mean, maybe you have y is -15 and x is +8. Or what if you have y is +15 and x is -8, right? That still gives you a -15 over 8. So you have to think about it, and you usually have some other condition. So in this case, you do. It says sine of theta is less than 0. So what that means is that the y value is negative, and then the x value is therefore positive. So it's going to be this one. It's not going to be that one. But you always have to think about that. You can't just assume the top one is the y and the bottom one is the x. So when we sketch it out, we go out 8. I'm not going to draw all the tick marks. And we go up 15, or sorry, down 15. Oh, close to getting a bonus point for corrections. So down 15. And we have some kind of theta. Okay, so here's my point, and I want to go straight towards that point. Now remember, we can use this as our theta, but it's not our actual theta. Our actual theta goes all the way from the initial x-axis, right, all the way to the terminal ray. Okay, so theta is actually here. So theta is some kind of value that is between 270 degrees and 360 degrees, or you could do 3 pi over 2 and 2 pi. Okay, but we're not worried about what actually theta is, although you could find it with inverse cosine, inverse sine, and so on. But we just want to know what cosine of theta is, and I made a typo. It should not be tangent of theta because we already know tangent of theta, right? That's already -15 over 8. So that's boring. So let's get rid of that, and let's say, what is sine of theta? Okay, so cosine of theta is going to be the x value over the r value. So it's going to be the x value was 8, the y value is -15. We still need to find r. So we do that with the Pythagorean theorem. So r squared equals 8 squared plus -15 squared. So I already found that for you. So it is going to be 17. So it's going to be the x value, which is 8 over 17. And notice how it's positive. Well, it's positive because it's in the fourth quadrant, right? And cosine is positive in the fourth quadrant. And then sine of theta is the y value over the r value. So the y value is -15 over 17. And it's negative because it's in the fourth quadrant, and sine should be negative. Okay, so if you're getting something that's not correct, think about your positives and negatives and kind of go back to this step here where you were eliminating things. All right, so it says evaluate the sine, cosine, and tangent functions at the 4 quadrantal angles, so 0, pi over 2, pi, and 3 pi over 2. Really the best way to do this, it doesn't really matter what your radius is. Okay, so you can always think about, so on the quadrantal angles at least, you can always think about the unit circle. So let's think about right here at 0, we have the point 1, 0. At pi over 2, we have 0, 1, we have -1, 0, and 0, -1. So if I talk about the sine of 0, right, we have the y value divided by the radius, but we don't, I mean, our radius is 1 in this case. Our radius could really be anything. When we do 0 divided by whatever our radius is, right, we still get 0. So then we have cosine of 0. It still ends up being 1, regardless of what you have. because your radius is whatever the length that you went out. Like this could be 5, 0, right? And then the radius would be 5, and the x value would also be 5. So it's kind of confusing. That's why I always say just think about the unit circle for the quadrantal ones. And then tangent of 0, oops, I did theta. Tangent of 0 is y over x, so it's still 0. All right, and then we go through the same process for all of the other ones. So like the sine of pi over 2, so now we're using up here. So it's going to be the y value, which is 1/2, cosine of pi over 2 equals 0, tangent of pi over 2 equals sine over cosine, so it's undefined. And then we talk about pi, so we have sine of pi is going to be 0, cosine of pi is -1, and tangent of pi, oops, I keep doing tangent of theta. Tangent of pi is going to be sine over cosine, which is 0. And then the last one, 3 pi over 2, cosine of 3 pi over 2, tangent of 3 pi over 2. So sine of 3 pi over 2 is going to be -1, cosine is 0, and tangent is sine over cosine, which again is undefined. So an interesting thing to note, which will be important when we graph, is that tangent can be undefined, and it's undefined at pi over 2, 3 pi over 2, and every, if I keep adding pi to them, I would get that. All right. So the definition of a reference angle. So I kind of mentioned it earlier. The reference angle is the acute angle where you could draw a little acute triangle and find the same values, find the sine, cosine, and tangent of the smaller angle. So if I talk about the reference angle for 330 degrees, well, 330 degrees goes almost all the way around, except it's 30 degrees away, right? So the reference angle is 30 degrees. So you could use a little triangle using 30 degrees. However, you don't want to draw it like this, right? You don't want to use a triangle like 30 degrees and then have the sine as positive and the cosine as positive, because we know at 330 that the sine is negative. So you can use it to draw a little triangle, but yeah, you really just want to think about the sine. Okay, so if I have -135 goes backwards in the negative direction. So its reference angle would be this 45-degree angle right there. So you've used this many times before, we just never really called it a reference angle. So then 4 pi over 3 would be going around, past pi, another pi over 3. So its reference angle, instead of calling it like 60 degrees, we'd call it pi over 3. Okay, so evaluate each trig function. Always think about what quadrant your original angle is. Don't just think about the reference angle. So what I will typically do is I'll keep subtracting 2 pi or keep subtracting 360 or adding 360 or whatever I need to do to get it to be something that is on my unit circle. So we can continue to use the unit circle on these ones. So if I have cosine of 16 pi over 3, 16 pi over 3 is bigger than 2 pi. It's not on my unit circle, but if I keep subtracting iterations of 2 pi, right? If I subtract one of the 2 pi's, minus 6 pi over 3, I'm at 10 pi over 3. So I actually should do it twice. So I'm not going to just subtract one of those. I'm going to subtract 2 of the 6 pi over 3's, 2 of the 2 pi's. So when I do that, I get cosine of, instead of having 16 pi over 3, I'm going to subtract 12 pi over 3, so I get cosine of 4 pi over 3. And that is one that I know, because we just drew it. It's right there. So the cosine, as you know, we go over a little bit, down a whole bunch. So the cosine is -1/2. Okay, so then cotangent of -570 degrees. So let's go ahead and add 360, and we're going to do it more than once. Let's add it twice. So if I add 720, I get cotangent of 150 degrees. So 150 degrees is right here. We know that that's over a whole bunch, -√3/2, up 1/2. So cotangent is the reciprocal of tangent. Tangent is always the y over x. Cotangent then is the x over y. So what we do is we take the x value divided by the y value, which if we write it out, it's -3/2 times 2/1 cancel, cancel. So we get negative root 3. Okay, and we continue this process. So cosecant of 11 pi over 4, you could try to subtract out, let's do 2 pi. So if I subtract out 8 pi over 4, I end up getting cosecant of 3 pi over 4, which we do now. So 3 pi over 4 would be here. It's negative root 2 over 2, comma, positive root 2 over 2. So cosecant is the reciprocal of sine. So it's 1 over sine of 3 pi over 4, which is the same as 1 over root 2 over 2. So if I do 1 over root 2 over 2, it's 1 times, I flip it, 2 over root 2, which actually reduces out to be just root 2. So you can do that. You can rationalize, or you could notice that 2 is root 2 times root 2, and then reduce out if you want to do it that way as well. Okay. And then the last one is the secant of 13 pi over 4. Again, we'll subtract out 8 pi over 4, because all it is just a rotation of the same, it's all in the same location. So I get secant of 5 pi over 4, which is here. So we know that's negative root 2 over 2, comma, negative root 2 over 2. So it's going to be 1 over negative root 2 over 2, which we just kind of did that. So now that's negative root 2. That's the answer. All right, so let's use our calculator a little bit. So remember, in pre-calc, you can switch back and forth between degrees and radians. So you always have to know how to change that on your calculator. So you can go to mode and switch from degrees to radians. So if you have cotangent of 415, you always need to know how to put that into your calculator. Cotangent, there is no cotangent button. So you would have to put in cosine of 415 over sine of 415. And I didn't say how many decimals to round to, so let's round to 4. Usually I say 3, but we'll do 4 this time. Okay, so if I do that, you could do it all together by putting parentheses. And you should get, let's see, 0.7002. All right, and then sine of negative 8, if there's no degree mentioned, then that's in radians. So when we do this, we're going to switch our modes, so we're in radians now, and we get negative 0.9894. And then secant of pi over 12, everybody has a hard time with secant and cosecant. They always panic. They think that it's the inverse cosine, and it's not. We'll talk about inverse cosine later. So do not use that. Okay, instead, what you're going to do is 1 over cosine of pi over 12, which is going to be 1.0353. All right, and then cosecant, if you do that one, it's going to be 1 over sine of negative 7 pi over 3, which is 1 over negative 0.8660, or you could do it all in your calculator all at once, and you get negative 1.1547. So there are your answers. All right, so the next thing. So it says let sine of theta equal 3 over 5, where theta is between pi over 2 and pi. Kind of the same thing that we did before. I use the word trig identities. You don't have to worry about what trig identities are right now. We're going to do a lot of those later. But it's basically saying just using the x over r, y over r, and so on. So if I have sine of theta equals 3 over 5, and I know that I'm in between pi over 2 and pi, that means that I'm in the second quadrant. Okay, so that's just important when we're drawing. We have the y over the r, and again, our x is negative 4. I like the 3, 4, 5 right triangles. So then your cosine of theta, like we did before, is going to be negative 4 over 5, and your tangent of theta is going to be your y over your x, which we'll write as negative 3/4. Okay, so that's kind of a review of the last time. These are going to get a little bit harder, though. So if I have cosine of theta equals 0.2, okay, I don't really know which ones are which. Okay, so it says find all angles, so I don't know what my my x, my r, and so on. I can make it 0.2 and 1 if I want to, but we actually don't need to. So it's saying find all angles that could be solutions for theta. So here's the tricky thing. If you do inverse cosine on your calculator, you only get one answer. So that's the frustrating thing. An inverse cosine, which we'll talk about later, has only one answer, okay? It has a unique inverse. So when we do this, we really need to sketch it out and think about what it's saying. So it's saying our cosine value is equal to 0.2. So if cosine is equal to a positive 0.2, that means that I could be here in the first quadrant, or I could be in the fourth quadrant. Okay, either one, it doesn't matter. Okay, so we're going to go ahead and do the inverse cosine of 0.2 on our calculator. And when we do that, we get, so that's equal to, let me write it out. So cosine of theta equals 0.2. So when I solve for theta, I get rid of my cosine, kind of like I'm dividing by cosine, or not really. I'm doing an inverse function, kind of like in Algebra 2, we talked about f of x and f inverse of x. So we're doing the inverse to get theta. So we end up getting theta is equal to 1.369. Okay. Well, let's think about where that's located. 1.369 radians. If you talk about pi divided by 2, pi is 3.14 divided by 2, right? Well, pi isn't exactly 3.14, but you get what I'm saying. So you get around 1.571 up there at pi over 2, right? So what answer is this? It's this one, 1.369. So then the question is, well, how do we get the second one? How do we get that? Okay, well, it's the same. It's just the opposite radian. It's negative 1.369 away, but we don't want negatives. We want on the interval 0 to 2 pi. Okay, so we have to think about how to adjust it. So what we end up doing is we take that negative 1.369 and we add 2 pi to it to bring it back around and put it in that interval 0 to 2 pi. So your answer is going to be 7.653. That's the other one. 2 pi is, ooh, I made a mistake, didn't I? I caught myself. 2 pi is going to be 6.28 around there, right? So I'll do negative 1.369 plus 2 pi. So it should be 4.914. Okay, so those are your two answers for theta then. So theta is not only 1.369, but it's also 4.914. Okay, so the next one. So secant of theta is equal to 1.5. Well, what does that mean? That means 1 over cosine of theta equals 1.5, which means cosine of theta equals 1 over 1.5. You just flip both sides. Well, 1 over 1.5 is 1 over 3 over 2, so it's 2/3. So we want cosine of theta to equal 1 over 3 over 2, which is 2/3. So we think about it. We're like, well, when is cosine equal to 2/3? There are two places, in the first quadrant and the second quadrant, or first quadrant and fourth quadrant. That's where cosine is positive, right? So we draw two random angles. So we're like, okay, cosine could be 2/3, cosine could be 2/3. We're here and here. And we do our inverse cosine. So we get theta is equal to inverse cosine of 2/3. Knowing that we only get one answer, so I have 0.841. Well, that's here, 0.841, right? It's smaller than that 1.571. It's in the first quadrant. It makes sense. So if I want to find the other one, I do my negative 0.841. But again, I want on 0 to 2 pi. If I wanted on negative pi to pi, I'd be good. I'd have 0.841 and negative 0.841. But that is not on the interval that I want. I want it to be bigger than 0. So what I do is I adjust it by adding 2 pi, right? I take it back around. So when I do that, 0.841 plus 2 pi, I get 7.653. 124. And that's the second answer. Okay, number 4. So number 4 says cosecant is equal to negative 0.72. So 1 over sine of theta is equal to negative 0.72. So when you do the reciprocal, you get sine of theta is equal to negative 1.389. So when you try that on your calculator and you do inverse sine of negative 1.389, you get error. Okay, it says something like domain error. So we think about it. Sine is always between negative 1 and 1. It's never smaller than negative 1, right? Sine is always between negative 1 and 1. So it makes sense that we're getting error. So this is a no solution because there is no way that cosecant can possibly be what it was, okay? So it cannot happen. So if you're getting error, think about why you're getting an error. So no solution is the answer. All right, so that wraps up lesson 16. And we'll do 17 next.